fitness center is interested in finding a 98% confidence interval for the mean number of days per week that Americans who are members of a fitness club go to their center. Records of 255 members were looked at, and the sample mean was 3.1, and the sample standard deviation was 2.6. So we're going to use a t-distribution here because sigma is unknown. So here are the rules for what distribution to choose. When sigma is unknown and the sample size is at least 30 or you have a normal distribution, you can use the t-distribution. So I'm going to find that confidence interval two different ways with you, one with technology and one with formulas. But first, let's write down all the information we're given. So we know n is 255. That's the sample size. X bar, the mean number of visits, is 3.1. The standard deviation sample, S, is 2.6. And our confidence level, we want a 98% confidence interval, so this is 0.98. So I'm going to jump over to the list of calculators, and there'll be a link to this in the problem. It'll also be in the module. And I'm going to pick on confidence interval for mean with statistics. All right, and now we fill in what we know. First, make sure that sigma unknown is checked because we do not know the population standard deviation. Then we enter what we know, 255 for n, X bar is 3.1, S is 2.6, and our confidence level is 0.98. Hit calculate, and there we go. When I round these numbers to 3 decimal places, I get that the mean number of visits is between 2.719 and 3.481. And finally, let's fill in part C. If many groups of 255 are randomly selected and studied, a difference confidence interval will be produced for each group. About 98% of those confidence intervals will contain the true population mean, and about 2% will not. Okay, now I'm going to show you another method using formulas. The error bound is t sub alpha over 2 times s over the square root of n. Alpha is 1 minus the confidence level, and in this problem, the confidence level is 0.98. So alpha is going to be 0.01. So what does that mean? In our t-distribution, if this is t sub alpha over 2, the area of this tail is 0.01. And so the area in the remaining piece must be 0.99. 1 minus 0.01 is 0.99. So I'm going to show you how to find t sub alpha over 2 using technology. If you're interested, I'm going to use Desmos. And what you do is you click on, make sure the keypad is clicked, and click on functions. I'll move this over a bit. Go down to distributions and choose inverse CDF, and then go back to functions and choose the distribution you want. We want the t-distribution. We have to enter the degrees of freedom. The degrees of freedom are 1 less than the sample size. So for us, that's 254. And then, comma, we enter the amount of area to the left of t sub alpha over 2. So that's 0.99. And we get t sub alpha over 2, 2.3411 to 4 decimals. So I have that recorded over here. And now we can compute the error bound. It's t sub alpha over 2 times the standard deviation s divided by the square root of n. And when I put that into my calculator to 4 decimals, I get 0.3812. Now I can create my confidence interval. We get the confidence interval by taking the mean 3.1 and subtracting the error bound on one side and adding it on the other. And when I do that, I get this interval, and to 3 decimals, that's exactly what we got before. I hope this was helpful.